A few weeks ago I posted a video where I make new gears for this magnificent piece of engineering on the shaper. And a lot of you asked me in the comments if I wanted to explain a bit how it works. Of course, let's do this. But first let me explain a bit what my background is, where I learned to make gears on the shaper. When I was in school, the teacher told us that cutting gears on the shaper, you have a cutting tool or something, and when the shaper is moving with some kind of wire, the thing spins. But it's all very complicated. That's all background. To me, it is obvious that the teacher in question didn't know himself how to do. I don't know a thing about making gears. I never learned in school how to use a dividing head or nothing. So what I'm gonna do here in this video is to explain how I do, not how to do. How I do. The story begins more or less when I bought this shaper. Now it was in really good condition, except for the lead screw and the lead nuts. And over the years there was more and more play in the thing. So what I wanted to do is to make a new lead screw. Of course, on the lathe. The problem I had with this lathe is that I didn't have the right change gears to cut the pitch I wanted. So I decided to give it a go and make some myself out of nothing. Several times I had the question, why not just make a cutting tool that has the right shape and plunge straight down in the gear blank using the dividing head. Now, of course, that is a brilliant idea, but making a cutting tool that has exactly the right shape is a challenge. I don't say it's impossible, but it's really not easy to do. Second point, my little shaper doesn't like heavy cuts. When you come at more or less full depth, this is the length of the cut. For the gears I have to make, or had to make, is more than 7 millimeters in total. A 7 millimeter cut on this small machine just doesn't work. And there's another point. The dividing head and the shaper are maybe not really made for each other. Too big. And so I was a little bit on my own here to figure out how to make gears on the shaper. And because I didn't know a thing about it, I did a little bit of research online. The online university, very handy. And so I figure out that these gears I need are module 1.5. No idea what it means, but 1.5. And I also found that the gear calculating is always done started from a gear rack, straight thing, not a circle. So in this case this is the pitch line, not the pitch circle yet. And the pressure angle for the module I have to cut is 20 degrees. Maybe the gear you're gonna cut will be different. That's why I will not go in too much detail, because all this information is really easy to find. You Google, for example, a gear calculator, and you have this thing. You put in the numbers, you know, right, what do we know? We know the pitch, we know the module, we know the pressure angle, and the number of teeth. In this case, for example, 48. And all the other numbers you need, your computer will give them for free. Now, if you know all the theory behind it, I will show you the two systems I use to make gears on a shaper. First, I will show you with the wire, and after I will show it with the gear rack. But this is the wrong machine. To start, I made this thing. That, of course, I mount on the table of the shaper. And I also made this shaft. This shaft, in theory, fits in here, and indeed it does. This is my gear blank I want to cut. This one is already cut and it works, but imagine it's not yet cut. Okay, use your imagination. I install it here. No, the other way around. This way around, because of course the cutting tool needs space to get in and out. Because in this gear the bore is bigger than my shaft, I made this little bushing. Now, of course, you don't have to do this, but I used the same thing for many different gears. This still works. And then here is a little hole. I had a set screw and there's a keyway in the shaft, so I could fix the thing in place. The gear is of course fixed on the shaft, cannot spin in relationship one to each other. This blank will be a 30-tooth gear. And I have here a template. Now, if you don't have the gear that you can use as a template, that's not really a problem. You can, for example, 3D print one or use a paper template that you can easily find online. Now, this comes from the Wooden Gears website. So you print it out, cut it out and then glue it on a piece of sheet metal, which works really well with wood glue, and then file the teeth. The only important thing is of course the distance between the teeth must be accurate. The shape of the teeth, we don't care. You can make a bigger template and drill holes. From the moment they're on the right spot, you're good to go. Right, I have a gear template that I put here. This side, the other side, I don't think matters much. And of course this gear is also keyed on the shaft, so all this becomes one piece. And then I made this bizarre looking thing. This comes here on the shaft, and there is a locating pin that I can turn in and out, and this locates of course in my gear. And so every tooth I cut, I can screw out, move the thing one tooth and then screw it in again. And so it is locked into each other. And here is a part of a cylinder. Now there are two, because this was for another gear, but the smaller one is for the 30-tooth gear. And this is of course to lead the steel wire or cable or whatever you want to call it. And this is how the assembly looks like. I will install the thing on the shaper table and explain a little bit more in detail how it works. And this is more or less the idea. The two-cut gear is of course this one that is fixed on the shaft use your imagination, it's fixed on the shaft. And here's my template. And the wire goes around the wheel and is fixed on both ends of the slide. And while the table is moving while cutting, my gear spins. If now I want to change, to cut another tooth here in the gear, all I have to do is loosen this nut behind here, and then I can see, but you can see, this little bolt with a point. I'm gonna put my hands in the way, loosen it a bit, turn the thing one tooth if it wants to. That's the problem, of course, working with cameras, don't see what I'm doing. Spin all the thing one tooth, we put the point in place and tighten the nut again. And that was the problem that I had with this system. When I tighten the nut, you see that there is some play. Of course, these two wires, this one wire, this wire needs to be more tightened than it is now. But I left it like this so you can see the problem I had. Even completely tight as a piano string, there was still movement. So my gear is good, it's okay, but it's not perfect. It is maybe important to note that the diameter of this little pulley where the wire goes, this diameter is the pitch circle of the gear I have to cut, minus half the thickness of the wire. Now that you know everything I know about shaping gears using the wire system, let's have a closer look how we can cut gears on the shaper using the rack. Of course, it's important that the rack you're gonna use is the same as the gear you're gonna cut. I mean by that, of course, module 1.5 for mine, so this rack module 1.5. The dimensions are really easy to find online, so no worries. A good question could be, of course, yes, but how about the cutting tool? It's very easy. We use the cutting tool as a form tool. So we need to make it exactly the same shape as we need for the gear rack. Same module. I don't think that's a problem. Of course, because in a rack the sides are straight, the cutting tool has also straight sides and the pressure angle both sides of the tool. That's all. And what I did to make this rack, I installed the tool slide at the pressure angle, 20 degrees. So my cutting tool cuts only one side and the bottom. A bit that idea if you cut a thread on the lathe, it's more or less the same idea. So it will not take as big cuts as if you plunge in straight. Of course, if you have a big and strong shaper, no problem plunging straight. Now the fun trick is this same cutting tool, we're gonna use it to cut whatever gear that has the same module. So the number of teeth, not important, always the same cutting tool. I want to make a 48 tooth gear. So I went online, printed out all I need to know. Now I made a very little mistake in the beginning of the video. The things you need to know to put in to make your calculating thing work is, and I will turn my paper around, the number of teeth, 48, the module, 1.5, and the pressure angle, 20 degrees. That's all you need to know, and the computer will give you all you need. For example, the total diameter in this case is, and I check, 75 millimeters. Right. I have installed a 48 tooth gear here that I'm gonna use as a template. The teeth of this gear, this one here, they are far from perfect. But in this case, it's not important. And the rack, of course, moves in the gear. No, the gear moves in the rack. And this is more or less the idea. We can see here where I touched off to install the 0. So in fact the cutting tool will not move in relationship to the cut. It's the whole gear blank that moves. My paper here tells me that the all depth of one tooth is 3.37 millimeters. But as I said before, this machine is not a big fan of heavy cuts. So I dialed in 2 millimeter cut, and then after I will recut 1.37. Let's make a gear. Tooth number 1 is cut and is finished, and I think you can see it right here. Now to cut the next one, all I have to do is to push this shaft out, spin it one tooth and engage again in the gear rack, and we're ready for number 2. I'm not gonna finish this gear because I already have one, so I have absolutely no need of this one. But it was just an example. I hope all this was more or less clear and complete. I think it is absolutely worth giving it a go. After all, there is nothing to lose. Take whatever gear out of your lathe and make a copy. All this is homemade out of scrap metal. I bought nothing. And if you see that your system that you make, that you want to make, for example, a small gear, and you put it on, of course, this one comes behind here, we see that the cutting tool will touch my system here. So that's not gonna work. And that's why I left this length here a bit like a spacer. So I put it here on the back side, and here I have room for the tool to go in and out. And after, when my gear is finished, I cut it off and I have an absolutely normal gear.